All right, so as I told you guys in class, we're going to continue this lesson in a video. We ran out of time today, so I'm going to pick up where we left off. All right, this is chapter 2, lesson 4, transformations in the plane. Okay, page number 95. I'm gonna kind of go back a little bit. I know there's a lot on the board, but kind of go back as we talked about reflections, translations, and then rotations. Those are the three things. Again, they're at the bottom of page 95, kind of give you definitions of them down there. I did mention to you guys about the points. Okay, we're going to be taking these. We're going to be doing reflections around the points. So reflection, translation, and rotation. This is kind of the breakdown of each of them. You're going to be given 3 points. You're going to be given a triangle. And the questions on the homework, and again, this is starting with page 103, numbers 9 through 20. They're going to give you 3 points. And they're going to say they want you to, let me read the instructions. I'll just tell you what it says here. Triangle ABC has coordinates, and they give you the 3 points, A, B, and C. Determine the coordinates of the vertices of the image after transformation. Now remember, we talked about you have your points, A, B, and C. For example, here's A. Now when you transform it, right, this is about the x-axis. I'll explain this in a minute. But once it's transformed, it has the little transformation, little apostrophe there. So it's A. And then your apostrophe. So this is transformed A is now this point. So I'm going to explain what this means. So for example, if you're doing a reflection, and they say they want you to reflect it on the x-axis, you take your point. This is an example for A. So let's say, let me see if I can do this in blue. See if my blue will work for me today. Okay, good. Let's say if my point was 3, 2. Well, if I'm going to be reflecting it about the x-axis, then it becomes my x. So my x is a 3, so it's going to be 3. And then y is it says it's going to be a negative y. So if it's a positive 2, it becomes a negative 2. So there's that's my transformed A. Okay, and it goes the same here. It goes for all of these. I'm going to give you I'm going to do some examples, but this is kind of the formula, if you will, for it. So I'm going to use this little space, probably. I'm kind of running out of space here to do this. Let me get rid of my example here. Try to keep this somewhat clean. All right, so inside here, make some space. Inside this little bubble, I'm going to do an example problem. So for example, I should probably get something to sit on here. Let me get one of these chairs. So for example, I'm giving you 3 points, and you take all 3 points and transform them. So let's say we're going to, let me see, reflection. Okay, about, let's see, and let's go y-axis. Now they're going to give you 3 points. Let me see. I don't know. All right, I'm backtracking here. Let me see if I can put this somewhere over here. Let's go A, I'll stick with 3, 2. B, negative 4, 0, and C, 12, negative 5. My examples, I'm going to use these 3 points. Again, your homework gives you 3 points, and you need to do different things: reflection, translation, and rotation. So, if we're using those points, A, B, and C from over there, and they're saying reflection in the y-axis, what that means is you're going to take your A. You have to take each point and then kind of transform them. So A is 3, 2. I'm going to transform it. Now it is A, again with the little apostrophe, so it's transformed A. Now when it transforms on the y-axis, it goes negative x. So what is my x? My x is 3. So it's negative 3, and then my y stays the same. So my x, right? My x becomes the negative, and the y stays the same. So this is what we're doing here. So then my y is just 2. This is A. Now I need to do B. Again, I'm getting my points from over there. They give them to me on the homework assignment, or on the question that you're doing, whether it's a quiz or whatever it is. So here's B. Now I'm going to transform B. And again, since it's on the y-axis, I'm still using this little formula. So my x becomes negative. So that's a negative 4. Well, what's a negative 4? It's just a positive. Okay, so what was negative becomes positive because it's saying I need to change my sign. And then my y stays the same, it's just y. So it was a 0, it stays a 0. And now c is 12, negative 5. As I transform c, so this is transform c, that's the little sign there. Let's see, a is negative, so it becomes negative 12. I'm sorry, x is negative because negative 12, and then y stays the same. Well, it was negative 5, so it stays negative 5. These are my 3 transform points. If you were to actually put these on a graph, your triangle would basically be reflected, right, on the y-axis. The y-axis is the one going up and down, so it's actually going to look like it's like a mirror, like it's going to flip-flop across that. All right, so that's an example of reflection. Okay, once you get the hang of these, it's just kind of plug it and play. There's really nothing too crazy with this one. So there's reflection. X or Y use the different formulas. Now keep in mind, let's see, I haven't done it yet. I'm going to make sure you guys have all the answers to the homework so that you guys are able to check your work. And again, as always, make sure we show our work. So that's reflection on the y-axis. Let's go back, or let's continue with translation. Now, when you're dealing with translation, it says in the textbook, I was going to read it to you so we can make sure we get this right. Translation is introduced on page 99. It talks about a translation vector, okay? To translate a point along vector AB, right? Here's my vector AB. Add A to the X and add B to the Y. So the way that it's going to be stated, okay, because you're translating it along a vector. So all we're doing is we're taking the A and B, we're adding them to the X and Y. Because we talked about translating is the sliding. So you're going to take your image, your triangle, and you're sliding it somewhere. Well, the sliding part is what the vector, that's what the vector does. It tells you which way it's going to go. So let's see here. We have, lost it. Okay, so let's do that. Let's do translation. Along, is that right? Along vector, and I'm running out of space here, of course. So again, vectors kind of written with these little triangle thing, you know, or these little greater than, less than signs, and it's A comma B. So let's go -4, 3. So our vector is gonna be -4, 3. So again, this is what we're using. So we're taking our X and we're gonna add A to it. And we're taking our Y and we're adding B to it. That's all we're doing. That's how you are transforming these. So 3, right? Plus -4. 3 plus -4 is -1. 2 plus the 3 is 5. That's how I transform point A. Again, it is your X, which is my 3, plus your A. Well, my A is -4. So 3 plus -4 give us -1. 2 plus 3 give us 5. For B, -4 plus -4 is -8. 0 plus 3 is 3. 12 plus -4. I wrote 12. 12 plus -4 gives us 8. -5 plus 3 is a -2. These are my new transform points. Again, this is how I want it done in the homework. Now, I didn't have enough space here to write it out, but you can write out 3 plus -4 and then kind of rewrite your final. But these are my transform points when I'm translating along the vector -4, 3. Okay, and last but not least is rotation. Now, when we're dealing with rotation, I kind of drew in class how you have, let me see, I'll put it back up here. I drew this in class. You kind of have like, this is 90 degrees, 180 degrees, 270 degrees, and this is like 360 or 0. The whole goal here, let me keep my little divider up. My whole goal here is that when you're transforming something 90 degrees, it's good to know that everything is clockwise. When they say counterclockwise, you need to think the opposite. So I'm going to do an example of clockwise and then counterclockwise in a minute. And you guys will see what I'm talking about, okay? Because on your homework, they give you both. So here's the formulas, or here's the way that it kind of works. If it talks about being clockwise or rotating 90 degrees about the origin, then you're using this little formula here. You take your x, and what you're actually doing, guys, if you look, you're actually taking these and you're flopping them, right? Whatever your y is goes first, and then you make it negative, or you change the sign. And whatever your x is, it goes last. So pay attention here. When you're going 180 degrees, all you're doing is just changing your signs. You're not changing any order. Change both your signs. Now, when you're going 270 degrees, and I didn't put my comma or my parentheses after here, you're swapping them again. Your x goes to the end and your y goes to the beginning, but then you're only changing the sign on the second one here. So it's a little tricky. So I'm going to do some of these and show you guys. Let me see if I can turn this way so we can see. All right, so for A, we are going to be rotating. Oof, these are rotation. Let's go. 90 degrees. I'm going to shorten it here because I'm running out of space. Rotation 90 degrees about the origin. That's how it would say, about the origin. I guess if they're written about the origin, that's fine. So 90 degrees. So again, we're looking at this one. So our x, right? If you look here, our x, which happens to be the 3, goes to the end. So it's actually going to be back here. And then my y, which is the 2, goes in the front. And then it says to change the sign.